right, thanks so much for having me, Daryl, and for organizing really cool talk so far. Excited to be here. I'll talk about engagement-based algorithms and how they disrupt our social norm learning. So we've kind of foreshadowed this with all the talks, but we're in a situation where polarization is high. And one of the things I want to point out is that the media clearly plays some kind of role here. Politicians, they're using outrage stoking and they're using moralization to galvanize their base. And arguably, there's an asymmetry on the left and right, but that's a discussion for another talk. Anger and hate, truly horrific. It's a liberal mess. I want to point out a few things. The first is that this is actually not a new thing. So in the US, at least since the 1970s, the political right has been pairing with the evangelical church in a way that has allowed them to use moralization to catalyze political action in their favor. Jerry Falwell actually had one of the highest ratings in TV news in the 80s, just behind HBO. And he was sending these messages of moralization and outrage stoking, some of which the rhetoric you might recognize from today. So the other thing I want to point out is that social media is doing something similar, but it also has some important differences that we should pay attention to. And the first thing I'll mention is that the online information context is participatory, which means that the moralization and the outrage stoking that elites are putting out there becomes more of a social reality because your social network engages with it. They are putting their own commentary on it. But what I'll be focusing on in today's talk is the fact that people's understanding of this social reality that they are receiving in their social media feed, well, it's influenced by content algorithms for the first time in human history. And I think we generally lack a good understanding of how that's influencing our understanding of the moral and political world. And so that's what I'll be focusing on today. And I want to introduce quickly, because I don't have a long time in this talk, a model that my colleagues and I have developed over the last few years that helps explain how the understanding of our moral and political world is influenced by engagement-based algorithms. So the first thing to note is that we are very good at social learning. And I want to draw your attention to work in cultural evolution literature that demonstrates that we actually learn from each other in a biased way. So we're not always the most accurate, but there are functional reasons for these biases. And the two things I'll point out is that we have context and content biases. We tend to learn from prestigious models, in-group members more rapidly. We pay attention to emotional information, moralized information, more so than other types of information. So why is this functional? Well, these have generally advantages in our evolutionary past. I'll focus on emotional information as an example. It helps us navigate and pay attention to survival threats, whether that's physical or social. For example, with moralized information, being able to detect cheaters in your social environment, that allows you to foster cooperation in the long run. So I want to point out a difference between the function of social learning and the mechanisms that underwrite that for humans, and the function of engagement-based content algorithms. These are designed to capture attention and maximize engagement, of course, because that leads to more revenue in the advertising-based models of these platforms. So the question that I want to think about in this model that we wanted to think about was what happens when you interact these two functions and what kind of behaviors emerge. Well, if you've been paying attention to what I said before, you might be able to predict the content that is most likely to capture our attention and maximize engagement. And so the past 10 years of research, including some from my lab, we've shown that content algorithms in practice, the way that they optimize engagement is by exploiting social learning biases. Well, I should say that's a prediction of our model that is actually supported from the research I was mentioning, which basically shows in observational data that there's a striking one-to-one correspondence between the content that spreads widely on social media platforms and this content that I've argued we have social learning biases toward. So we call this prime information, prestigious in-group, moralized, and emotional. And so our model of how this all works is the following, and I presented a QR code so you can read this in more detail. But basically, as I've argued, let's look at the A path. We all have these biases to attend to prime information. Now let's look at the B path. We predict that engagement-based algorithms, because of their function to maximize engagement, in practice, they amplify that prime information. And then to me, what is the most interesting is how we learn from the content that the algorithms are amplifying. Because remember, social media is collaborative, and we're not just amplifying content, but we're amplifying people who are posting content. And so our social learning mechanisms immediately kick in. What we argue is that through this interaction, because this process leads to an overrepresentation of prime information, it disrupts our social norm learning. And we actually make inferences about moral and political content that don't really represent the underlying base rate of content. And that's what I'll be presenting some data on today. We argue this leads to conflict and misinformation. So how do we study this in kind of the proof of concept first pass? We also have done this in the field now, but I only have time to present one experiment, so I'll do the first. We collaborated with MIT Media Lab, and we modified this paradigm they have called Your Feed. So ultimately, what it allows us to do is assign participants to different conditions. We have full control over the kind of content that might show up in their feed. But importantly, we can modify the behavior of an algorithm that will control the content they see, and we can train the algorithm based on different features. So here's an example of what that looks like. And the really cool thing, this is related to something that Chris was talking about in the last talk. They can engage freely. They scroll like on a social media platform. But what we're doing, we're measuring actively the dwell time. So how long each stimulus stays on their screen. And then, of course, what they're engaging with actively. And so it's a nice unobtrusive measure of their attention. And one of the things you might notice is, well, dwell time is not a great measure of attention. It's very noisy. However, this is what social media platforms use as one of their key metrics to track engagement. So we think it's actually very important to study. So in our first study, we just wanted to know what kind of content actually gets amplified by engagement-based algorithms in a controlled setting. In the field, it's actually quite hard to disentangle things like selection effects, user behaviors from the actual algorithm. So this was an excellent case to be able to isolate the effects of engagement-based algorithms. So first of all, we developed and validated a large stimuli set of social media messages that we purposely manipulated on certain prime dimensions. I'll just show you a quick summary here. Basically, what I'll be focusing on in this set of results are dimensions of emotional, in-group, out-group, and moral content that vary based on blame, praise, and non-moral and political content. So we have both Republican and Democrat out-group blame, in-group praise. This is across several polarized topics. We also had political content that was just stating facts that didn't have any partisanship tied to it. And then we had non-political messages. And so in the first study, we're actually just going to show participants a random sample of this big database of content. And we're just going to study what do they naturally engage with, what do they naturally dwell on. And then we're going to train an algorithm that will then create feeds over time based on real participant behavior. So we had 2,000 participants, both Democrats and Republicans, and ultimately this algorithm is using a very simple weighting metric, which is just saying whatever content participants tend to like or dwell on more, we're going to over time rank that content higher. And then there's a random parameter that is basically if you set that to 1, that will be a true random sample from the feed. So the first key result, what I'm showing you here are the distributions of feed content that emerge over time after participants engage with the platform. And the first thing I want to point out is that this gray polygon represents the true base rate of content that we have in the underlying social network. So we set this, so we know it's skewed highly non-political, which by the way is actually a better representation of the content that people post online, even though sometimes it seems like this isn't the case. So what happens when you train the algorithm and over time, what does that feed start to look like? Well, across participants, what we see is that when we focus specifically on dwell, so we also have the opportunity to separate different engagement-based metrics to see how they behave, we start to see that political facts become highly overrepresented and also outgroup blame. And the other thing I'll note is that on this chart, anything to the left of the center is going to be in-group bias content. Anything on the right of the center is going to be out-group bias content. So then when we look at the actual clicking, the likes and the shares, we see very large in-group bias and even more bias toward blame and in-group praise. And so in summary, what we see is that blame, praise, and political content are all amplified by the engagement-based algorithms. But importantly, compare it to the gray polygon, we know that these are overrepresentations because we're controlling the true base rate of content in the underlying social network. Now, the next question we wanted to ask, what happens when participants are going to keep engaging with these feeds? And then we're going to ask them questions about the norms of the network that they're currently in. And so what we did is we randomly assigned participants to view different kinds of feeds. One was a control that represented the true random sample. So across participants, it represents the true underlying base rate of content in the social network. And then we have our dwell-based feed ranking and our like-share-based feed ranking, like I showed you before. So we asked participants about both descriptive norms and prescriptive norms. And the reason why we looked at both is because prescriptive norms tend to predict behavior more, so we thought both were important. I'm going to just show you the results for blame because that's related to moral outrage and polarization. But if you're interested in the other outcomes, I can talk about that later. But what we see is that for descriptive norms, very strong effects where people in the engagement-based algorithm feeds, they actually over-perceive the commonality of blame in their social network. And we know it's an overrepresentation because, like I mentioned, the control represents the true base rate. When it comes to asking about the social appropriateness of posting content, we also see a significant increase in both conditions. And this also represents an overperception because of the fact that we understand what the control condition is doing. So people think it is more appropriate to post blame in their network. And although I don't have time to show the results, we show in mediation models that this predicts both intentions to post blame. And then in another study, they compose their own messages, and LLM classification shows increased blame posting in the engagement-based algorithm conditions. So I only have, I think, a minute. So I will just mention that we also think about what kind of interventions could work really well to reduce this overperception. And basically, in a bridging-based algorithm, these are very popular right now. It weights content that are liked by both sides of the political spectrum higher. So if Democrats and Republicans like content, they both like it, then we'll weight that content higher. We'll downrank other content that's more polarizing. Well, very quickly, what we show is that, yes, this does work in reducing the blame that you perceive and the normativity of blame that you report. But notice on the far right compared to the control, actually, it leads to an underrepresentation of your perception of the prescriptive and descriptive norms of blame. I would argue that that is also not a great result because it leads to norms that are also inaccurate. So that's something I'd be interested in talking to you about in the Q&A. But yeah, just in summary, engagement-based algorithms overrepresent prime information, and that's due to the amplification of human biases. Prime information gets overrepresented. That leads to social misperceptions in terms of norm learning. And then bridging-based algorithms, they do reduce those perceptions, but maybe not in a way that actually leads to accurate norm perception. So I have ideas about how we should actually be thinking about interventions, and that's something I'm testing in the field at the moment. So thanks a lot. And if you're interested in this paper with the data, here's the QR code. And thanks to all my collaborators.
All right, maybe time for like 2 quick questions.
I think this was a really interesting set of studies, uh, like particularly manipulating people's feeds. I think that that's really interesting. I was looking at the effect sizes in the study particularly, and I saw that, for example, in study two, they seem to be quite large, but it seems that, compared to the control condition, where, for example, like around 40% of people perceived like blame is common. I think like it was not that above, for example, it like in share algorithmic situation condition, it was not like hugely above, for example, 60%. So although like the Cohen's d effect size seems to be like large here, do you think this would translate in like would this be practically significant? Is my question basically.
Yeah, I think that's an excellent question. It depends what you mean by practically significant. We show that it does actually translate to increased likelihood of posting blame content to the network. So in my opinion, that's excellent evidence that it is practically significant because it potentially is going to impact people's behavior. And yeah, when you scale this to the social network level, when you're dealing with millions and billions of people, it's actually something I am quite worried about because even if you have a small amount of people doing it, I think that scales pretty drastically. And another thing we know about online social networks is that it really doesn't take a lot of people to dictate the extreme content because the engagement-based algorithms are going to overrepresent those people.
Thanks. And I see the next speaker, James Floman, does have a question. You can go ahead and just say it out if you want, James.
Okay. Hi. Thanks for your talk, William. I kind of have two questions, which if we may not have time for both. Which emotions do you think are most active in Prime? Anger and outrage has come up a lot in this conference, but are there other emotions, perhaps positive emotions, that might matter as well? And if you can speak to like the emotional complexity inherent in how the functions are optimized. And then I had a question about the effects on mental health from algorithms like this, but that may be something we can discuss another time.
Yeah, excellent question. We do see evidence, I didn't have time to show this, that these positive emotions associating with praising the in-group, if you stick to the literature, you might call these things like awe or even elevation in the moral literature. But we do see evidence that these are engaged with and liked, and it gets amplified through the algorithms. The difference is smaller compared to negative emotion. So we do see this kind of bad is stronger than good effect that has been documented in observational data online. But there is room, I think, to think about how can we change that asymmetry because people are attracted to the positive emotions. And I think it's something that we need more data on.
Thank you.
Yeah, really fascinating work, Billy. And we should definitely talk more about the motivations behind the effects you're seeing as a function of the bridging algorithms are really interesting in terms of how it's shaping perceived norms. We have some correlational evidence that people will regulate outrage differently depending upon what they perceive. But thinking about how do people calibrate in both either a positive or negative direction is quite fascinating. So thanks.